Bismillahirrahmanirrahim. We continue our discussion on data communications and network. This lecture is the continuation of previous discussions on this chapter. Previously, we discussed different concepts related with the data communications, and then we started an introduction on computer networks. So in today's discussion, we will continue the computer networks topics and discuss further more important concepts related with computer networks. Let's proceed with the discussion agenda, the topics that we have discussed so far, and what we are going to discuss in today's discussion. Let's have a look at the discussion agenda. So this is the discussion agenda we are following in this chapter. We continued, or we discussed different topics related to data communication that include developing an understanding with the topic data communication, that is mainly the mechanism by which data is transmitted between 2 points is known as data communication. Then we discussed different elements related to data communication. We discussed different elements, 5 different elements, out of which 3 are basic. That is, there must be a sender who sends or creates messages. Then there must be a receiver, who is again a computer who receives the messages. Then there must be some communication media through which data is transmitted. That can be wired media or can be unwired media. Then the data itself, we also call it a message that is required to be sent, or the communication media from the sender to the receiver. And then the 4th important element that we discussed were the protocols, or the set of rules that is required to ensure the data communication mechanism. Then in data communication, we discussed its different types, that are serial and parallel data communication. In serial communication, data is communicated bit by bit over a single transmission line, while in parallel communication, data is sent in shape of groups of bits over multiple channels at the same time. So serial communication ensures slow data communication mechanism, but the format it is sent is received in the same format. But since parallel communication uses different communication medias, it is fastest mode of or type of communication, but again it may happen that some of the data may be received earlier while others may be received later, depending on the communication media or the distance between the sender and receiver. Then we discussed different modes of communication. 4 modes of communication have been discussed, that include simplex mode, duplex mode having 2 further types, half duplex and full duplex, then asynchronous mode of communication and synchronous mode of communication. So these were the 4 topics that we discussed on data communication in order to develop a background on computer networks. Then we developed an understanding on network in previous lecture. So data communication is one of the reasons to develop a computer network. So in previous discussion, we discussed what is a network. So network is basically the interconnection of different computers or electronic devices through some communication media. Why we require to develop a network? there are different reasons or different uses or different benefits that computer network brings along, and we have discussed them in detail in previous lecture. Then we discussed how data network actually works. So both the required software and required hardware need to be there in order to a computer network work properly. What are different elements required to form a computer network? We discussed 4 different elements in order to form a computer network, in which there were computers or electronic devices that would act as computer sender, receiver, and the data forwarding devices. Then there must be the communication media, both either wired communication media or the unwired communication media. And then there must be the communication protocols, the protocols required to set up the communication or data communication between the two parties. And the 4th important element to form a computer network that we discussed was the networking softwares that ensure how data must be communicated, or how data must be formatted, or how data path needs to be developed is done through some networking softwares. Then we discussed different types of networks. Some are private networks and some are public networks. Public networks are accessible on public areas, while private networks are accessible to some limited specified area. Private networks are more secure as they do not provide access to some unauthorized member or device, while public areas, since they are publicly accessible networks, so they may not be as secure as private networks. So these were the topics we discussed related to network in previous discussion. In today's discussion, we are going to discuss different modes of transmission of data within a network. We discussed modes of data communication earlier, and we discussed 4 different modes mainly. That includes simplex mode of data communication, duplex mode of data communication, synchronous mode, and asynchronous mode. Now we have to see what are the modes of data transmission in a computer network. So let's proceed with the topic and see what are different modes to send and receive data within a computer network. Basically, modes of data transmission within a computer network. By this we mean what are different switching techniques available within the computer network. So modes of data transmission is mainly we are referring to different switching techniques. When we deal with large networks or long distance data communication or data transmission is to be required. So it cannot be directly done without any hardware support. We need some dedicated path for our data packets to be sent on a path. So switching technique mainly refers to selecting the suitable path that will be followed by your data on a network. As so many choices of paths are there on which data may travel, we need to select some specified path. So this path selection or this path on which our data has to travel, this technique is known as switching technique. The path that is selected by the data to travel from source to destination is known as switching. So there are three techniques for switching, or three switching techniques are there commonly. First technique is the circuit switching. Circuit switching is the first common technique. Circuit switching mainly develops or establishes some dedicated path between the sender and the receiver. This is similar to the synchronous mode of communication. If you remember, we discussed modes of data communication and we discussed synchronous mode of communication as one of the data communication technique. So circuit switching is similar to synchronous mode of communication. So circuit switching establishes a dedicated path or channel between the sender and receiver for data transmission. And once this dedicated path is established, so it then cannot be terminated until the connection between the sender and receiver gets terminated. Circuit switching operates in similar manner in which a telephone network operates. When you call someone, the dedicated communication channel is established between you and the receiver to whom you have called. So that ringing of bell of your phone is actually the mechanism how the path or dedicated path is going to be established. So once the call is received, the path has been developed. Now you send the data, you speak on the line, the other receiver receives your data, responds you back, and unless and until the call has been dropped, the channel or the dedicated path remains there. One of the sender or receiver, when switches off the call, only then this dedicated path gets terminated. So circuit switching works similarly to your phone networks, telephone networks, the way you call someone. Now let's suppose you try to call someone through your phone. Before transmission of your message takes place, the request signal is first sent to the receiver in shape of phone call bell. The phone bell rings to the sender, and if the receiver approves your call, if he picks up your call or notifies its availability by sending back the acknowledgement, this then means that the dedicated path has been established. If he picks up your call, the dedicated path is established between you and the receiver. So after receiving the acknowledgement from the receiver, so when the call gets connected, when the receiver is on the line, then sender transmits data through this dedicated path. In circuit switching, fixed data can be transferred at a time. For example, it is used in public telephonic networks for audio transmission. This is the common example of circuit switching. So in diagram you can see we have two computers or we have two users. Different paths are there. One is this path, another is this path. That means different nodes, the transmission nodes in between are there, and one is this one. So it is important that first a bridge is to be developed between the sender and receiver. So appropriate path is first found. Here you can see the link has been developed between different interconnecting nodes. Here you can see first the sender is connected to this node. This node can be the forwarding device or another computer. Then this node forwards the data to another node, who then forwards the data to some other forwarding device, and ultimately the data has been forwarded to the receiver. But before sending the data, this path needs to be established. Once the path is established, then data is sent from the sender and received by the receiver. While communicating through circuit switching, a message has to go through 3 phases. So circuit switching operates in 3 phases. First phase is known as circuit establishment, similar to the phone bell. When your phone is ringing, that means it is the process of circuit establishment. Second phase is the transmission of data. When you receive the call, that means path has been established. Now the sender will send the data or talk to you. This is the transmission of data phase. And last phase is the circuit termination phase. That means when one of the user, either the sender or receiver, disconnects the call, then this circuit that has already been developed gets terminated. So it operates in 3 phases. It has to first develop the dedicated path, the communication channel, then it has to transmit the data, and after data transmission is completed, the dedicated path needs to get terminated. So what are the benefits or advantages that circuit switching brings? Circuit switching is the technique in which a dedicated path or channel is established. That means it ensures the data delivery. So when you develop or when you establish a communication channel between 2 parties, that means data delivery is ensured. Second benefit that it brings is it improves the data transmission rate. Since there is no interference between the path here, as you can see in the diagram, no interference in the path, no other node can interfere in this dedicated path. These are the other nodes here you can see. So these nodes cannot interfere in this dedicated path. So data cannot be disturbed. So transmission rate is improved. Another benefit that circuit switching brings is there is less chances of data loss. If you develop or if you establish a dedicated path, that means whatever you send have 100% chances to be received. So less amount of data loss may happen only if there is a distortion between the channel, the communication path that has been formed. If the distortion is there, it generally may happen that you are not able to listen to the other party due to the problem in the communication channel or the path that has been formed. So if that happens, only then data loss may happen. Otherwise, if the connection is completely and clearly established and you clearly are listening to the sender, then there are very less chances of data loss. Whatever is sent is ensured to be received. If there is a distortion in data communication, so the channel is terminated by any of the 2 parties and the channel is developed again. So when you find distortion in the call, you drop the call and you call back in order to ensure whatever is being sent by the receiver are received by you. Next benefit that is provided by circuit switching is that it improves the delays in data flow. The benefit of developing dedicated path is that there is no delay in data transmission. So in whatever time it has been sent is ensured to be received at the same time, and it is only possible due to the establishment of this dedicated path. So whatever is sent at whatever time is received at the same time. There is very less chances of delays in data flow. Now, apart from the benefits or advantages, circuit switches may bring some disadvantages, but the disadvantages are lesser than the benefits that it brings. What is the disadvantage? Establishing a dedicated channel takes long. So, it may happen that you are ringing your fellow and he is not picking the call. So, it may take some time to establish the dedicated channel. The other receiver may not be available or whatever the reason, but the path is not getting established. So, establishing the dedicated path may take some time. And since circuit switching says, unless and until the dedicated path is not established, there would be no data transmission. So when you call your friend, unless or until he does not answer your phone, you are not able to transmit the data. So it may take some time to establish the path. If he is not answering the call, you cannot send the data. Whenever he would receive the call means the path is then established. So the dedicated channel may take some time to establish, and another disadvantage is that even if channel is free, no other device can use it. The dedicated path is only developed between two parties. No third party can interfere in that dedicated path. So if you are not using that dedicated path, for example, you have called your friend, he has received your call, but still you are on hold, that channel cannot be used to communicate with another party. It is meant to be used by the parties it has been developed between in. So if the channel is free, if your call is on hold or you are not talking on the line, still that line will not be used to communicate with another party. This is another benefit, another disadvantage, sorry. But since circuit switching brings a lot of benefits, so it is considered a good switching technique. Second switching technique is the message switching. Message switching was developed to act as an alternate to circuit switching. It was developed before the packet switching technique. In message switching, the end users transmit data in form of messages. So data is sent in shape of messages, which consists of entire data that is required to be shared. What is a message? A message is mainly a smallest individual unit of data. So unlike circuit switching, there is no dedicated path established between the sender and the receiver. Hence, they are connected through, the sender and receiver are connected through different intermediate nodes that help to ensure proper data transmission. There is no dedicated path, keep in mind, but different interconnected nodes are there to ensure data transfer. Now, what is a node? We already discussed what a node is. A node within a computer network can be some other computer or some workstation. So these messages are switched. Data networks are also known as hop-by-hop system. Message switching can also be known as, or can also be called as, hop-by-hop system or node-by-node data network. It has two main characteristics. message switching has two main characteristics. First one is store and forward. Since users are not directly connected, that means there is no dedicated path established between the sender and receiver. So the intermediate nodes, the nodes between the sender and the receiver, are responsible for transferring the entire message to the next node within the path. So the nodes between the sender and receiver have the responsibility to receive the message and forward it to other node in the path. In order to do so, every node must have some storage capacity, because a message will only be delivered if the next node and the link between them are available to connect. Otherwise, the data or the message will be stored indefinitely. So the two nodes forwards data to one another only if the other node is ready to accept the data sent by the previous node. So if the other node is not ready, the previous node has to store the message sent by the sender. So for that, nodes must have some storage capacity. Since there is no dedicated path, in between different nodes are responsible to forward the message, take it from sender and forward it to the receiver. And how they do it? They send it node by node. So every node must have the storage capacity, as it has to store the message received from one node and then informs the other node that it is sending the message. But if the other node is not ready, so the previous node has to store the message for long, unless the connection is established between the next node. So it is called store and forward property of message switching. It is also known as store and forward technique or store and forward switching technique. This technique was earlier used in telegraph message switching networks. The second property or second characteristics is the message delivery. The complete information is compiled into a single message, and that message is then transmitted from source to destination. So a complete message is first created and then it is sent from sender to receiver. So in order to successfully reach to the destination, every message contains the routing information in its header section. A message is formed in shape of, you can say, a notebook. So you write your name, your class, your details on the first page of your notebook. Similarly, the first page of this message contains the routing information. That means which destination it is required to be sent, the address of the destination. So whenever a node receives this message, it reads out the first page of this message and then sees where is the destination ahead. And if it can forward the message directly to the destination, it can do so. But if cannot, it is too far away, it sends it to the other nearby node. So the message is then passed on to the other node. The other node again reads out the header information, the first page of the message, to know if it is the receiver or the receiver is someone else. After reading the address of the receiver, it then forwards the message to either the destination if it is nearby or to some other node. So this is how routing takes place, hop by hop or node by node. Message switching has its benefits. What are the benefits? It has the capability, as every node has the capabilities to store the messages. So since there is no dedicated path, but your message is ensured to deliver, but before that it may take time to deliver your message, but before message is delivered, message is stored maybe for long on intermediate nodes, unless the other node or the destination is available to deliver the messages. Another benefit is that it reduces the traffic congestion. How traffic congestion is reduced? It does not allow too many nodes to take part in this process. Only respective number of nodes that are between the sender and receiver are required to take part in this process. And if all the nodes are active, the traffic flow is quite consistent and quick. So it reduces traffic loop flow. That means data flow is not stopped, interfered, or blocked in between. Another benefit is that the data channels are shared. Since no dedicated path is formed, so a node may be a node or a forwarding node for one sender and receiver, while it may act a forwarding node for another sender and receiver pair. So the nodes within the senders and receiver are working for different parties. That is why this data communication technique, the nodes within this technique can be shared by different parties. This is one of the beauty of this technique. It manages traffic efficiently. That means there is no need to create the path, no interference between any party that is ensured by the dedicated path. So here that means in dedicated path no other device can use that path, but here all the nodes are shared, all the nodes can be used as intermediate nodes by different sender and receiver pairs. So the traffic is efficiently managed. That means if a data is meant to be sent between one party and if it is meant to be sent by another party, that can be done simultaneously. So one node is working for one pair and it may be working at the same time for another sender and receiver pair. So this is the benefit of message switching. Besides some benefits, it brings some disadvantages as well. For example, data may be stored on the intermediate nodes for quite long. That may cause delays in data transmission. As I just said, a node stores data for some time until the other node in the path is ready to receive the data. So it may take some time, and some time means it may take at times quite long, and this may cause delays in message delivery. Dedicated path ensures data delivery quite quick. Once dedicated path is established, data is transmitted. But here, even if the receiver is available to receive the data, but the intermediate nodes may not be ready to receive the data. So for that, in that case, data delivery may get delayed. Another disadvantage is whole network requires higher storage capacity. As this mechanism says, every node has to store the data for some time until the next node in the path is ready to receive the node. So every node must have the storage capacity, which is not possible for every computer. A node means a computer, an interconnecting computer. So every node may not have higher capacity of data storage. So this is one of the disadvantage if it is used as a switching technique. The last mode of data communication is the packet switching. As in circuit switching, a dedicated circuit or a dedicated path is required to be developed for data transmission. But let's assume if we want to send some small amount of data. Circuit switching is generally formed to send a large amount of data. But what if we are to send small amount of data? So here packet switching works efficiently. Packet switching technique transmits data through the network by breaking the data in several small data packets for efficient data transfer. So packet switches breaks down the data in small packets. It also utilizes numerous vacant resources in shape of network devices that forwards, directs or route the data packets to the destination, where the receiving device then collects all of them and reassembles them in order to get the proper message that was sent. Here you can see in the diagram, there is a sender and a receiver. Sender creates a message. The data is divided in small packets. So here you can see 4 data packets are formed, A, B, C, D. There is no dedicated path. Keep in mind, in packet switching, there is no dedicated path formed. So these are different interconnecting nodes. Here you can see these are all the nodes in blue color, which have the capability to forward the data between the sender and receiver. So these data packets, every packet is moved on a different path to the receiver. So you can see A follows this route from node by node and ultimately reaches to the receiver. Packet A. Then B follows this route. Here you can see the central node and reach to the destination. C follows another path. Here you can see it follows this path and reach to the destination, or it may not reach to the destination ultimately. Some of the packets may have fallen down, and D also follows this path to reach to the destination. So different packets are routed on different paths using different nodes, and it may happen that the receiver may not receive the packets in the same order it has been sent. So then receiver reassembles those packets. Packets are labeled as the way they are forwards in shape of, for example, 1, 2, 3, in this case ABC. So it then reassembles them in order to understand what data or what message has been sent from the receiver. Every packet follows different paths between the sender and receiver. So some of the packets or the packets that were sent late may be received earlier, or the last packets may be received earlier than the first packets. So the receiver then has to reorganize or reassemble the packets in order to understand the message that has been sent from the receiver, from the sender. So what are the benefits that packet switching brings? It is highly efficient as it uses the complete network to send the message. It does not require to develop one common path between the sender and receiver. Instead, it uses the complete network. So it may follow the fastest paths or the nearest paths that can send the data from sender and receiver. So overall network capacity is utilized or managed in this type of data switching. It is faster as compared to the circuit switching. Why? Because circuit switching takes a lot of time in establishing the circuit, while this technique, or it is even efficient than message switching. Why? Because in message switching you need to have the storage capability, and the storage may take long if the other node is not ready to receive the message. So the node may have to store the message for quite long time. But here, if a node is not ready to receive the message, the node may then forward that message to any other node nearby. It may not wait for the next immediate node. So in this way, this technique is faster as compared to the circuit switching and message switching. Another benefit that it brings is that it is a fault tolerant technique. Packet switching is quite fault tolerant. That means if some of the path is down, for example, few nodes in the path are down, so the packets that are routed on those nodes are then rerouted on some other node. So for example, in this diagram, let me clear it first. In this diagram, if this path is down, or the nodes, some of the nodes over this path are down, and some of the packets were routed on this node, so those packets are then rerouted on other nodes. For example, this node, this path can be followed, this path can be followed to reach, this path can be followed to reach to the destination. So it may not have to wait for a path to get fixed and then it has to send data. Rather, it has to select other alternative paths. So this is fault tolerant technique. It is quite cost effective. Why? Because it does not require to develop any dedicated path. So whatever node is in between the sender and receiver are used to forward the message. So it is quite effective and quite quick technique. It is reliable. Why reliable? Because if some nodes are not working, still our data will be delivered. Why? Because alternate nodes or alternate paths are formed between the sender and receiver. Alternate nodes are working to ensure data is transmitted from sender to receiver. So it is more reliable as compared to the circuit switching technique, where we rely on the dedicated path. So if dedicated path is distorted, data is not transmitted. But here, if a path is distorted, so the packets are routed on other paths. It is quite complex. Why it is complex? Because packets are out of order when they are routed or on the network, and they are out of order when they are received by the receiver. So the receiver may take some time to reorganize the message in order to understand what has been sent. Secondly, it is complicated. Why? Because it is complicated. The interconnecting nodes here, you can see these nodes are quite complex. That means there are too many nodes in between the sender and receiver. So it may happen several number of nodes can take part in forwarding a message from sender and receiver. It can bring further delays, which can bring further complexities if some of the node gets down and data is not forwarded from that node. So that packet of node will be then sent again by the sender. So if receiver receives the message and it does not find the correct sequence of the message, so it sends the signal back to the sender that some of the packets are not received. So then sender has to resend those packets again. But before that, those nodes which were not capable to forward that packet, so those nodes are to be identified so that packets are not again sent on those nodes. So it further complicates the situation. What are some of the disadvantages of packet switching? It is not suitable for applications that does not require delays. As we just said, packet switching is most effective for small amount of data transfer. So if you are sending some sensitive data or data that is time constrained, so this packet switching technique is not efficient or not effective for those type of data communications. So if you are communication requires quick quick data transmission. So this technique is then not appropriate. For that, you need to develop dedicated paths, and as in case of circuit switching. It requires high installation costs. You would require to have a lot of intermediate data forwarding nodes. That means a lot of routers, a lot of switches, which would bring installation cost. Different complex protocols are required. Protocols, as we said, protocols are a set of rules that ensure how data is to be communicated. So quite complicated set of rules need to be written, in which they have to identify which node is working, which node is not working, which node has the capability to forward the data, which path is working. So all those information need to be established in the protocols before sending the data from the sender to receiver. And then another disadvantage, errors may be introduced in packets. As I just said, some of the packets may have fallen down if a node is not working and the packet has been routed through that node and the packet has not been received by the receiver, so that packet has to be resent by the sender. While some of the packets may tear off, some errors may have been introduced while passing from sender to receiver, since it is not a secure mode of communication. Secure is only if there is a dedicated path between the sender and receiver. Since it is not a secure mode of communication, so packets may get tear off during its traveling and errors may be introduced. So whatever is sent may not be properly understood by the receiver. So receiver then asks for resending of some of the packets if errors are introduced in some of the packets. Now we have to discuss what are different types of networks. We have already discussed different modes of data transmission within the network. 3 different modes have been discussed. Modes of data transmission is actually how data is routed. So different switching techniques have been discussed that include circuit switching, basic switching and packet switching. And now what are different types of networks that we are going to discuss in next slide. As we send computer network, or as we just said, computer network is the group of computers that are linked to each other, that enable a computer to communicate with other computers and sharing resources, data and different applications. So a computer, there can be different types of computer, and computer networks can be categorized in 3 types. How categorization can be made, or on what basis data networks are categorized? They are categorized according to their size. So types of networks are mainly dependent on the size of network. The first type of network is the local area network, which is the smallest as per the size. This is the smallest type of network. So local area network is actually a group of computers that are connected to each other in small area. In small areas such as a building within an office. So this is the smallest type of computer network. It is commonly used to connect 2 or few computers as inside a building through some communication media. The communication media may be wired or may be unwired. Local area network is less costly. Why? Because very few computers are required. Here you can see very few number of computers are required to be connected. Generally, wired media is used, but today in latest technology we can also use unwired media to connect different computers. So this is quite less costly as it is built with inexpensive hardware such as hubs, network adapters and Ethernet cables if in case of a wide media. So data travels here quite fast. Why? Because very few computers are connected. No third party is allowed to interfere here, so data transmission is quite fast within local area network. And it is considered as quite secure as compared to any other type of network. Why? Because tight security protocols or tight security measures are provided within local area network, as local area networks are generally formed within a building, within an office. So it is easy to secure few computers as compared to larger networks. Another type of network is Metropolitan Area Network. It is a network that covers a larger geographical area, higher geographical area as compared to local area network. That means different LANs are connected together. This is one LAN, this is second LAN, this is third LAN, and this is fourth LAN. So different LANs are connected together to form a metropolitan area network. So it covers a larger geographical area by interconnecting different LANs to form a much larger network as compared to local area network. Different government agencies use MAN, Metropolitan Area Network, to connect to the citizens and private industries. In Metropolitan Area Network, various LANs are connected to each other through the telephone exchange line and has higher range as compared to single LAN. So, local area network was smaller in its size. Metropolitan area is higher in size as compared to local area network, and they are mainly connected through telephone exchange lines and maybe now unwired media for communication or connection. Where it can be used, it has uses, such as it can be used for communication between different banks within a city. So a bank may communicate with its different branches within a city through MAN. So a LAN is developed inside a building office, inside it one of the branch, another branch may have its lane, so two lanes may communicate to form a MAN. Similarly, it can be used in airline reservation system. Different office of airline may have their respective LANs which then communicate with one another to form a MAN. And similarly, it can be used for the communication within the military. So different offices within a setup can communicate with one another to form a MAN. So metropolitan area basically connects two or more than two different LANs in order to form a higher communication range, which is known as metropolitan area network. Another type of network is wide area network. It is a network that extends over a large geographical area, such as different states are connected or different countries are connected. So long distance transmission of data is if required. So for that we can use wide area networks. It is quite bigger than LAN, and also it is quite bigger in size as compared to metropolitan area network. It is not limited to single location. Instead, it spans over larger geographical area through through telephone line, fiber optic cables, or through satellite links. Internet is one of the example of wide area network. So internet is the common example of wide area network. It brings different benefits along. For example, it has a centralized infrastructure. Centralized infrastructure is one of the main advantages of wide area network, that we do not need to maintain the backup and store data on local system, as everything is stored online on some centralized data. So you do not need to now store your data on every computer. Instead, data has been stored on some centralized location, from where you can easily then access your data. For example, your emails are stored on some centralized location, so whenever you connect to your email, your data or your emails are received from that particular computer. Another benefit that it brings along is the privacy. Wide area network can be set up in such a way that it encrypts the data that is shared between different parties. So data encryption is generally done using different protocols, as we discussed previously. And the data is then secure and also minimizes the risk of unauthorized access. So whenever you send data through wide area network, that data has been encrypted. It is not sent in the same form you send it. So data is encrypted. That means data privacy is ensured to some extent. Another benefit is increased bandwidth. Increased bandwidth. On wide area network, we can have the liberty to choose bandwidth on the basis of our need. For example, a bigger organization may require a much higher bandwidth that can carry large amount of data, while your home networks may require small amount of bandwidth, as your use may not be of that level. So bandwidth is dependent on the number of use or on the type of use user generally have. Another benefit is the larger geographical area. Wide area network covers larger area. Even the whole world is connected through internet, and it is not possible in any other type of the network that we discuss, such as local area network. Does not have the capability to have larger geographical areas such as wide area network, and similarly MAN. But there are some disadvantages of wide area network. What are those? First is that you would require antiviruses. For example, if you are browsing or surfing the internet, you may find some malicious content that are downloaded on your system. So in order to protect your system, you would require an antivirus. Antiviruses are used for the protection of your data and your system for any type of data loss or any type of malicious activity. So wide area network may harm your system with any type of malicious content. Secondly, it is expensive. Why expensive? Because the cost of installation of wide area network is quite high. The fiber optics or the satellite waves that required to establish wide area networks in case of unwired communication. So the setup is quite expensive. Why expensive? Because you are going to connect to the whole world, so it would require some expensive or installation cost. And then issue resolution. If you find some issue or your internet is not working properly, since the whole world is connected over wide area network, so it is quite time taking to locate the issue, where the issue is, on which node, on which forwarding device the issue is, and then to resolve that issue, it may take some time. So issue resolution takes a lot of time on wide area network as it covers larger geographical area. So it is quite difficult to pinpoint the exact error location or exact issue location which can cause the problem. Once the issue is pinpointed, then it may also take to resolve the issue because there can be, due to the wide geographical area, there can be you can face seas in between, you can face the forests in between. So the data transmission between all these different areas, it may be quite time taking to reach to exact location of the issue point and then to fix it. That is all. Here we come to the end of data communication and network chapter. In today's discussion, we discussed different nodes of data transmission in computer networks that were actually switching techniques that we discussed. We discussed circuit switching, in which a dedicated path is established between the sender and receiver. We discussed message switching, that was mainly hop by hop data forwarding technique, in which there is no dedicated path is established between the sender and receiver, but the message is forwarded with the help of different intermediate nodes. Then we discussed packet switching, in which the data is broken down into small packets, and those packets are then forwarded using different paths or different intermediate nodes. So in whatever format it has been forwarded, it may not reach in the same format. So the receiver then rearranges those packets in order to understand the message. Then we discussed different types of networks. So mainly there are three types of networks on the basis of size of the network. So the smallest one is the local area network, which is a network or an interconnection between two or few computers within a building or an office. So it has smaller geographical area coverage. Second type is the metropolitan area network, that mainly connects different lands within a city. So that makes local area network. And then we have wide area network as WAN, that connects different countries, different states, different continents in a network. So it has higher size, higher geographical area as compared to LAN and MAN. That is it with this chapter. I hope you have understood the concepts we discussed. Still, if you have any confusion or any query, you can ask me on KCMS or email me. My email address is written here. That is all for now. I thank you all.